Hello, everyone. Uh, Great to see lots of people rolling in here. We'll start in about 1 minute's time just to let people come in nice and quickly, and then we'll kick off.
Yeah, right about this time, it would be nice to have some music in the background, right? Just as you were discussing, Tim, a little while back.
Exactly. Some nice background music there. Maybe the Top Gun theme. I don't know.
Definitely not elevator music, right?
That would make it even. Maybe that would be the prank by Erin, who does the organizing of our webinars. She can do
Yep.
just to make the silence a little bit more awkward.
Maybe next time.
Just giving you ideas, Evan.
Yeah, do it
Writing them down, writing them down.
if VJ or Alex doesn't treat you just perfectly.
Yeah, add background music to their webinar.
All right. Okay, I think we'll start here, and we've got a couple of introductory slides, so people who join a little bit late, they'll be fine. So thank you everyone for joining us today. We're going to have a webinar on disaster recovery in Postgres, what every DBA needs to know. So I'm joined here with my friend and master of Postgres, Umair Shahid. I'll give him a proper introduction later on from Stormatics. But before we kick off, just some really quick housekeeping. Okay, so we do have closed captions and translations available for this webinar. So you can go down there into the bar of Zoom and you can select some translations if that makes it a little bit easier for you. If you do have any questions, please put them in the Q&A during the webinar. I'll answer some where I can, or so might Umair, and then at the end of the session, we'll do more in-depth Q&A as well. This will be recorded, so we will follow up and send this to all of the attendees, this webinar or the recording of it, and you'll get that in your email. So what's on the agenda for today? So of course, we're going to be looking at Postgres and the difference between disaster recovery on Postgres and Oracle. What are some of those differences? Umair is going to explain a little bit about the similarities of some of the different features that are available. We're also going to discuss a little bit about RPO and RTO, how does that kind of work, and some of the core tools for Postgres. I think what's going to be of real value as well, Umair's implementing a lot of Postgres solutions. So some discussion around, there's a lot of tools out there for Postgres. What are some of those tools and which ones are actually getting used? What are some of the gotchas? What is a recent case study of customer implementation? So, what's happening in real life rather than the blogs that you can kind of see and read. And of course, questions on that will be great. Okay, so really quick 2 minutes on who DBVisit is. So we are disaster recovery specialists. We've been doing disaster recovery for 20 years. And we're founded from the idea that great disaster recovery should be really easy, should be easy to implement, and it should be painless to manage and utilize when it comes down to it. So we currently have 1,900 customers in 120 countries around the world. We deliver that from New Zealand and our service center in Prague as well, and another office in the USA. And we really want to make, one of our mantras internally is to have happy DBAs. And we do have customer satisfaction of, I think, 99.7% this quarter, which is great. And we have a 95% renewal rate. So we offer that disaster recovery for Oracle Standard Edition, where we started, SQL Server, and Postgres. And that's why we're doing a lot of our customers are on Oracle. And so we want to introduce the different tools and technologies available for Postgres. And that's why we have speakers like Umair come in and really give knowledge to the community about Postgres. So who is this gentleman sitting here? This is Umair Shahid. He is an absolute Postgres expert and the founder of Stormatics. Also really deep in the Postgres community, involved with EDB. And how many years have you been working in the Postgres community, Umair?
22 and
Wow.
counting. Yeah.
Yeah. And so quite a bit of change, I guess, and now really a mainstream solution for, production databases and an option for anyone thinking about production databases. So I'll let Umair, maybe you can do a little bit of introduction about what kind of work you and Stormatics are doing.
Sure. Thank you, Tim. So yeah, as you mentioned, as Tim had kindly introduced, I've been in the Postgres space for a while, for more than 2 decades, and Stormatics is focused on providing professional services for Postgres. This is our core focus. Any and everything that you need to do with Postgres, we provide a service for that. Our intent is to allow organizations or help organizations that want to leverage the Postgres database to use it in critical production environments, scale it, make it resilient, make it reliable, and make it fast. So we provide 24/7 support. We provide remote DBA services. We provide the services like health checks, trainings, etc. And we contribute to the open source ecosystem around Postgres to make the tooling even better based on the experience that we gained from the field working with clients. So yeah, day in and day out, we are living and breathing Postgres.
Excellent. So yeah, a really great source of, thank you for coming in and talking to some of our customers and potential new clients about, especially Oracle DBAs, about how Postgres is working in the wild.
Mm-hmm.
All right, so I will hand over to you. I will stop the share and there you go. Can you share now? Yeah, there we go.
Okay, I think, can you confirm that you can see my screen?
Yes, I can see that. No problem. Excellent.
Okay, great. So we're here to talk about disaster recovery in Postgres. The content today is oriented towards Oracle DBAs. So the idea, one of the things that we have experienced is lots of legacy systems, lots of large-scale deployments have been leveraging Oracle for a long time. The ecosystem and the talent and the skill set around Oracle is solid and reliable. Increasingly, however, organizations are adopting Postgres, and what we've discovered is that it is fairly straightforward to cross-train Oracle experts on Postgres. Many of the concepts are the same. Both databases are ANSI compliant. Both databases comply to the SQL standard. Both databases provide very, very similar functionality when it comes to the day-to-day operations of a production database. As long as we can understand the differences between the two databases, what we've found is that it's very easy to cross-train DBAs across these technologies, which is why we're talking about focusing on disaster recovery. We're talking about this kind of the cross and interchange.
I guess the biggest hurdle is really probably the terminology, right? To get your head around the terminology at the start.
Yes. So I think that many of the broader concepts remain exactly the same across these technologies. In terms of the tooling and in terms of how you achieve those, they differ. And some of the nomenclature also differs slightly, and that could be a barrier. And the whole point of this session is to try and address that barrier.
Exactly. Yeah,
right.
Great.
So disaster recovery, one of those terms which is common across both databases. Disaster recovery means pretty much the exact same thing across both Oracle and Postgres. It's the ability to recover from a disaster with as little injury as possible. So disasters can happen And what you want to do is be prepared for a disaster so that you're able to recover from it and with minimized losses. And losses are basically either measured in time or data or both. So the idea is to minimize the recovery time and minimize data loss. Disaster recovery is an absolutely critical component of any production database deployment. Mission critical applications rely on their databases to be always available, to be resilient, and to be reliable. So any mission critical application cannot afford to lose their data. And I think that one thing that I found resonates really well with everybody that I talk to when I try and give examples is pretty much all of us work with some bank or the other. We use credit cards, we use bank accounts. You probably never want to hear your bank call you and say, hey, by the way, we've lost your data, so you have zero balance now. You don't want that to happen, right? So those are the kind of applications and industries that cannot afford to get hit by a disaster and lose time or data. So any database that's hosting all of the data needs to be resilient. And that resilience is measured in RTO and RPO. RTO stands for recovery time objective, and RPO stands for recovery point objective. I'm sure that our audience from the Oracle background today will recognize both of these terms because they mean, they're used and referenced to in the Oracle world, just like they are referenced in the Postgres world. We talked about minimizing recovery time and minimizing data loss, and RTOs and RPO is what governs that. I tried to create a visual of it. I'm not sure, how good it is, but I think that it will help us convey the concept at least. So the idea of RTO, which I think I'm trying to.
Yeah, I can see it.
Yeah, it's it. Yeah. So the idea of RTO is, you've got a timeline on the horizontal axis right here, and you've got standard database actions taking place in the timeline, and maybe somewhere around this time, some kind of a disaster strikes. It could be something as simple as a network outage. It could be a fire, an earthquake, an entire city or an entire block losing power, whatever it is, flooding, natural disaster, anything, a disaster strikes and the database becomes unavailable. The recovery time objective, RTO, measures the amount of time it takes to get from here to here, where normal operations can start again. Now, within this time period right here is when the database is not available and the operations cannot continue. Generally, the idea is to minimize this time to the extent possible. Typically, the objective is to bring it as close to zero as possible. Bringing it to absolute zero may not be possible, but keeping it to as close to zero, that's the objective. So visually speaking, this is what the recovery time objective would look like on our horizontal timeline. Now, if we try and visualize what recovery point objective would look like. Now, over here, it's a very similar horizontal timeline. You've got normal database operations taking place, and then some disaster strikes over here, this time right here. The application continues to perform, and it is issuing selects and commits and whatever database transactions it is trying. And between the time when disaster strikes and when operations go back to normal, because the database becomes unavailable, the commits are lost, right? And this is the data loss that I was referring to that is measured via RPO. Again, the idea is to minimize this RPO, minimize this time and the number of commits lost to as close to 0 as possible. And that is, the data loss or the objective that we are speaking about. The idea, the whole objective is to ensure that data loss is minimized. That's the recovery point objective. Let's move forward. Now, another point that I wanted to address is I have seen that as we speak to people, at times the concepts of high availability and disaster recovery kind of overlap, and sometimes people get confused between the two. And I wanted to try and draw a clear line between the two concepts, the concept of high availability and disaster recovery. So one major difference is that HA is preemptive in nature. The idea is to prevent the database from going down or becoming unavailable. Disaster recovery, on the other hand, is reactive in nature. And the idea is, in case the preemptive measures fail, how you can very quickly go back to normal or recover from the disaster. So HA is preemptive in nature. Disaster recovery is reactive in nature. HA's example would be to have redundancy in place with primary and replica databases forming a cluster with hot standbys that are ready to fail over as soon as one node goes down. So you've got a cluster. We discussed this in our previous session, so I don't want to get into it in too much detail, but essentially a cluster that acts as one, and the nodes can add the redundancy, and in case one node goes down, the other can take over. Now, in case the entire cluster goes down is when the disaster has struck, and now you need to recover from the disaster, and that is the reactive nature of DR. High availability is typically implemented within a site, close range of each other, because as there is redundancy, as these nodes are talking to each other, we want to minimize network latency and the distances that the data is traveling so that the performance of the cluster is kept up to par. If the nodes are placed far from each other, the performance goes down because the data does need to travel across these nodes and it takes more time. So high availability typically is implemented as a cluster within a single site. DR, however, is typically recommended to be on a remote site, because let's say there's a disaster. Let's say there's flooding. If you have all of your nodes in a cluster in the same in the same data center, even if they are in different parts of the building, if there's flooding and the entire building goes down, then your entire cluster is gone. You want to have your DR set up in a remote site to add redundancy so that in case disaster strikes one location physically, you can recover in a different location and still be able to continue operations. So again, this is another difference between the two concepts. The concepts that are used in high availability are replication and failover. So data is replicated across these different nodes. Primarily, it goes from the primary node to the standby node. And in case the primary goes down, the standby can fail over. The primary node gets taken out of the cluster and the standby takes over. So the concepts are replication and failover. Disaster recovery also uses some part of replication, but the focus is on backup and restore and write-ahead logging. We'll talk about write-ahead logs in just a little bit, because that's a concept that is a little different in Postgres than it is in Oracle. But essentially, the difference that I want to highlight is that DR is related to backups and restores and point-in-time recovery.
Yeah, I think one of the key points here, I guess, for Oracle DBAs, Oracle people would be where replication often in especially streaming replication and solutions like Patroni But even singular streaming replication would often be called high availability, with a hot standby would be called high availability on Postgres. However, a similar solution like Active Data Guard is actually considered disaster recovery on Oracle. So there is a little bit of difference there, but probably those two terms in how it's treated. So if you go to a Postgres event, a lot of people will talk about high availability, whereas they would be talking about disaster recovery. And for Oracle, the real high availability solution is, has a SAN and is shared storage solution. So slight difference there, but in general, the concept of what they're trying to achieve is the same.
Yeah. So thank you for highlighting that, Tim. I believe that in the Oracle world, the way I've experienced it, and the disclaimer, of course, is I'm in no way an Oracle expert by far. So please take anything and everything that I say about Oracle with a grain of salt, and please feel free to keep me honest over here. But in the Oracle world, I understand that high availability is implemented via the Oracle RAC solution. And the concept of RAC is that it has multiple nodes sharing a single storage.
Yeah, that's right.
So it's shared storage across multiple nodes. That concept of shared storage does not exist in the Postgres world, right? So if you want an exact alternate to RAC in Postgres, you won't find it. Postgres implements it a little differently, and it is via replication. So shared storage does not exist, but every node is a data node, and data is shared via replication. So again, a bit of a difference, and thanks for taking the opportunity to kind of highlight that difference. The last point that I wanted to highlight as part of this slide is hot standbys versus warm standbys. High availability depends on nodes that are waiting in a hot standby mode that are ready to take over as soon as there is a problem with the primary node. You can also use these hot standbys for load balancing. So you might want to direct your write queries to the primary node and the read queries to the standby node. So kind of load balancing, so that not everything falls on a single node. You can actually leverage those resources as well. You can't load balance a warm standby. Warm standby remains in recovery mode at a remote location, and it is also not a complete data node in a way that it is ready to take over as soon as something happens to the primary. You have to do some intervention in order to ensure recovery from a disaster using a warm standby. It's not automated in nature. Hot standbys will automatically take over. Warm standbys will not automatically take over. They will need to go through a process of disaster recovery in order to stand them up as something that's an alternate to your primary server. So again,
I've just a bit of a question there. In the real world, do you still warm standby definitely still out there, but is available as an option. But do you still see people still using warm standby when hot standby is available, even as a DR kind of setup?
Good question. And I'd say that it might go against the instincts to even think about warm standby, knowing that a hot standby is available. Hey, you have a standby available, might as well use it for load balancing as well. Why need a warm standby? But if you dig in a little deeper, the whole concept behind a warm standby or a DR location is for it to be in a remote place, in a place that is different from where your primary cluster exists.
Mm-hmm.
Now, the way things are set up, the difference between a hot and a warm standby, the replication and the logging of data between the nodes in a single cluster are very strict by nature for a hot standby, because it is hot and it is designed to be ready to take over the moment the primary goes down. the replication is strict in nature, which means that you can't afford to have a whole lot of lag between your primary server and your sandbox.
Right.
Right. However, in a remote location, if you implement that sort of strictness, what you might end up doing is that you might end up slowing down the entire primary cluster to allow that remote server to remain in sync with the primary. So what you want to do is allow your primary cluster to move forward at the fastest pace possible, and the warm standby can catch up later. Right? Because it's in a remote location, it cannot stay caught up all the time. You can afford for it to get caught up a little later, which means that in case a disaster strike, there is the chance of some lag and some loss of data as well. But it impacts the performance if you treat that remote location as a hot standby.
Right.
So if the warm standbys continue to be effective if you don't want to load balance, you just want to have a recovery node. You don't want to have a full node, mostly just storage, and in a remote location such that you have the ability to recover from a disaster, but your primary node continues to function at high speed.
Right. Got it. Yeah, I think one important thing to point out for people here is, yeah, hot standby can be used for reporting purposes. And for Oracle, that's, people used to Oracle, that's quite cool because to get that kind of functionality within Oracle, you need to use Active Data Guard, which can be, requires Enterprise Edition and extra licenses. But with Postgres, you can implement a hot standby and do reporting and analytics off that standby database within the, open source license.
Yep. And again, a good point, Tim. Yeah, I probably should have said it in the beginning of this session. Everything that we're discussing in this, all the functionalities and the features, these are all open source Postgres. So we're not talking about any commercial proprietary licensing anywhere. All of this functionality, all of these features that we're discussing, they're all open source Postgres.
Yeah,
Okay.
and yeah, sorry, I'll just highlight load balancing in this case. I think you're relating to rather than, for example, load balancing the same database or some users accessing that database between nodes. You're actually referring to load balancing through reporting. Is that correct?
So when you say, load balancing to the same database, help me understand what you mean over there. Then, I might be able to answer better.
So I mean, rather than load balancing by putting different connections or different users accessing different nodes with the same database. So this is actually talking about load balancing through using the standby for reporting purposes or analytics. Is that correct?
Yes. Although you could have different users talking to different nodes of the cluster. I'm just very crudely drawing a 3-node cluster that would look roughly like this. That would be your primary. This would be your first standby. This would be your second standby. Forgive this absolutely horrid drawing, but hopefully it gets the message across. The idea is that the application is writing to the primary database. You could have the application read from the same database, or you could say, let's not put the read pressure on the primary. Instead, let's read from one of the standbys. That's one way to look at it, right? Now, it is important to understand that any write operation has to be to the primary because replication has been set up in one direction. It's not a multi-direction replication, right? It's a single direction replication. So the data goes from the primary to the standby 1, from the primary to the standby 2. Data does not go from S2 to P or
Right.
S2 to S1, right? So you cannot write to S2, you cannot write to S1. The writing has to be done at P. Now, if there are different users that have different kind of roles, and a few of those users only have read operations, then they can be directed to S2, right? Say
Yep.
you have a BI application running on the side. This application needs to pull data in to generate reports periodically. This can exclusively just talk to S2, or it can be configured to talk to both S1 and S2, so that even for the reads, one node is not overwhelmed.
Perfect.
Right?
Yeah, that's a great explanation.
So yeah, forgive my crude drawing. I actually had nice diagrams for stuff like this in our previous session, but you're just gonna have to make do with this.
No, I just like
for now.
putting pressure on you to draw it on the fly, Amir.
Oh, you're testing me. Okay, I'll keep that in mind for the future. Okay, so we're going to move forward. Now, again, I want to remind you of the disclaimer that I am in no way an expert in Oracle. And my understanding of DR in Oracle is kind of reproduced in this slide. And again, in case I got something wrong, please keep me honest. So the way data guard works in Oracle, you can get both physical and logical replicas of the databases using data guard. And I understand that it is the primary tool of choice if you want to implement disaster recovery across different sites. So we talked about, how it is important to kind of segregate your sites so that in case one site goes down in its entirety, the other sites can take over. So, it's a data guard seems to be the primary tool for this. RMAN, I guess, I think that it stands for Recovery Manager. RMAN is the framework that encapsulates data guard and implements the functionality of the backups and restores for full protection. So where data guard is one component, RMAN is kind of like a superset that encapsulates that component. The feature for flashback implements point-in-time recovery, rollback, or in simplest of words, implements the Control-Z functionality in the database. In case something goes wrong, you can actually roll back and go to a previous point in time. RAC, we discussed RAC a little while earlier. It shares storage, and multiple nodes can connect to that shared storage. The application can write to each of those nodes, and all of that data goes into a single storage. It provides high availability within a site, and it tends to be the go-to tool for implementing HA. I know that this session is about DR, but because HA and DR kind of go hand in hand for most part, I wanted to kind of bring this up as well. HA being preemptive and DR being reactive nature. Now, the our attendees for this webinar, if they're coming in from the Oracle background, you probably already know this stack well. You probably already work with this stack in Oracle, or at least are aware of this stack in Oracle and the functionalities that it provides. What I wanted to say is that Postgres offers parallel functionality, similar capabilities. The approach, however, is a little different. The tooling is a little different. And as I mentioned, that you will not be able to find an exact equivalent of RAC in the Postgres world, but you can implement high availability in the Postgres world in a slightly different way. And there are toolings that are available. Approaches are different, but the objective is the end outcome, which is the same. Now, the way disaster recovery works in Postgres, let's go through these points one by one. Streaming replication. This is physical replication. Now, what physical replication means that the physical data files on disk are streamed to the replica. the actual files are streamed. Those files are called write-ahead logs in Postgres, and vol for short. The write-ahead logs are streamed to the standby server. The replication can set to be asynchronous or synchronous. Asynchronous replication means that the files are shipped to the standby and the data gets committed on the primary server without waiting for a confirmation from the standby that it has received the data. So the primary will receive the data, commit it, stream it to the standby, and the standby will commit it when it receives it. In case of synchronous replication, however, there's a handshake mechanism that is implemented, which means that the primary receives the data, it ships it over to the secondary or the standby. The standby receives it and sends confirmation back to the primary that I've received it. And it is then that the primary commits the data. Now, the advantage of synchronous replication is that you know that your primary and the standby are always going to be exactly in sync. The downside is because of the back and forth of data exchange and that handshake mechanism, it takes more time, which means that the performance of there's a performance impact on the entire cluster. Now, there are some applications where the users are willing to take that performance hit in order to get the absolute reliability of synchronized primary and standby nodes. In some cases, the users are okay with having a little bit of a lag between the standby and the primary and implement asynchronous replication so that the primary can perform better. The streaming replication can be implemented in these two different ways. Now, what happens with, when you're replicating data is that the write-ahead logs are streamed to the standby, and they are continuously archived on the standby. And that's archiving that enables point-in-time recovery, whether on the standby or on the primary. Now, how it is done, again, I'll speak on that in a bit more detail in a subsequent slide. But essentially, it's a combination of the last backup that you have taken and the archived write-ahead logs after that backup that come together to implement disaster recovery as well as point-in-time recovery. I'll speak on that in a bit more detail in a couple of slides. There is tooling available to implement all of this and handle it in production. PG Backrest is a popular tool. Backrest, is basically it stands for PG Backup and Restore. RMAN, very close to RMAN, it stands for Backup and Recovery Manager. And again, much like RMAN kind of encapsulates the data guard functionality, PG Backrest and RMAN encapsulate the replication, backup, and restore and vol archiving functionality inside of Postgres to give you a tool within which you can set up your disaster recovery policy and strategy. They allow for parallel backups and restores. Both of them allow for incremental backups. You can back up and restore to and from the cloud. You can compress these backups. You can encrypt these backups. There are retention policies that you can implement. So these toolings can provide you with that functionality. There are tools available for high availability as well. Petroni, Rep Manager, PG Pool are examples. And essentially what they do is they help with the with managing the cluster that you've set up with replication. So we talked about how a 3-node cluster acts as one. It's tools like Petroni, Rep Manager, and PG Pool that allow you to manage such clusters. Yeah. So again, the emphasis is that the end outcome or the end result is the same as you get in Oracle. It's just that the way it's implemented behind the scenes in Postgres is a little different, and the tooling is a little different. The outcome for high availability and disaster recovery remains the same. Now,
One question we've got here that kind of fits in, Amir, is when you're using can you do your backups, for example, from Barman or something like this? Can you do those backups off the standby? And would that have to be off? Can it be off a warm standby, or does it have to be off a hot standby?
you can run your backups from a hot standby. A warm standby is created via backups and wall archiving.
Right.
So the whole definition of a warm standby is that it's done via those base backup and then wall archives beyond it, right? It's not an active standby. So you can run your backups from the hot standby, as long as you understand that the standby might be lagging slightly behind the primary, depending on the replication lag between the two.
Yeah. I mean, what I know it's always different, it's going to be different between different setups there, but is there, when you're using asynchronous streaming that you explained, what kind of lag are you typically seeing? But is it minutes or seconds or tens of minutes?
Yeah, I get constant feedback that you say it depends a lot.
That's a DBA's favorite
and unfortunately, yeah, that's the answer to most of the questions that I get asked. But let me describe to you what it depends on. It depends on the load that is being put on the primary, the settings that dictate how much data to retain in memory, how often to flush that data to disk, how often to ship the write-ahead logs to the replica, and how much load is being put on the replica. Now, if the entire mechanism is tuned and configured properly, typically the replication lag is fraction of seconds, a small fraction of second. It will almost be in sync, the two. Right? But in case there is very high load on the primary server, as well as very high load on the standby as you load balance, and there's a lot of data flowing not only from the application to the standby, and from the BI setup, from the standby to the BI setup, but also between the primary and the standby. That load might result in a lag that is bigger than what we would like to get. And replication lag, by the way, is one of the things that we closely monitor in production clusters. So we want to make sure that the replica is not lagging too far behind the primary. Right? Typically measured in seconds, not in minutes. Minutes is too much.
Yeah. No, that's great information.
Okay. My crude attempt at trying to map Oracle terminologies and tooling to what's available in Postgres. So the functionality that gets implemented in DataGuard, you can get in Postgres streaming replication, in open source in core Postgres. RMAN, the recovery manager, you get similar functionality with Barman and PG Backrest in the Postgres world. Oracle Flashback, you can get similar functionality with point-in-time recovery and write-ahead log archiving. And you can recover to a particular point in time. Oracle RAC, there's no direct, there's no exact counterpart in the Postgres world, but you do have the ability to implement a logical active replication setup in order to have multiple nodes that can take write operations. But you won't get shared storage. The storage will still, or the data will still be replicated across those different nodes. So Postgres relies on replication, not on shared storage.
One question I've just got there quickly. So in Oracle, I'm pretty sure, and correct me if I'm wrong, audience. So Flashback is usually used for the primary database where we want to avoid a failover situation and we, move back to a specific point of time, reverse some changes. Whereas I think maybe you're talking more about recovering to a point in time using the standby database. If you're wanting to move, let's say you've just got a single primary and you're not going to the standby, is there any tooling where you can kind of go back in time on Postgres as well?
So in terms of a hot database, a live database, and just reversing it to a particular point in time, that functionality does not exist in Postgres. The way you achieve that is by restoring the last backup and then replaying the write-ahead logs to the point in time that you want to replay to. So with flashback, you get the functionality of being, so if let's try my crude attempt at drawing again. So if this is your timeline, and this is your last backup, and this is where some kind of a disaster struck, right? In Oracle, you can, the flashback probably allows you to go from here backwards to this point where you know that there is some sane data over here. So you can go back over here and then start again. In Postgres, you don't have a means to go backwards. What you do is that you start from here, you replay these logs to get here.
Right.
So if the objective is to get to this point, this is how you do it in Postgres. You get to this point, but you can't go backwards. You have to move forwards.
So our developers talk a lot about PG Rewind. Is this the functionality that they're talking about?
PG Rewind is a little different, and that's a concept that is more aligned with the high availability.
Right.
So imagine in case you have a primary node that fails for some reason and a standby takes over. Now, once it has taken over, the primary comes back online, but now it needs to get synced up to this new primary that has taken over. So what PG Rewind allows you to do is to take most of the data that this old primary already has, compare it to all of the changes that have been made since this went down from the new primary, and make sure that all of those changes are captured in this old primary so that it can now become a standby to this new primary.
Right. That's without having to recreate the whole database again.
Exactly. So recreation is going to take a long time because you have to pull the last backup and you have to replay all the write-ahead logs, and depending on the amount of data, that could take hours or maybe even days.
Yeah.
You want to avoid that. You want to reuse that data, and PG Rewind helps you do that.
Yeah. Okay. Great. Thank you.
Sure. Okay, let's continue moving forward. This is a visual representation of how the write-ahead logging works in the streaming application. You've got the application writing to the primary node over here. All of that data gets captured as write-ahead log records. And when you have two standbys, the data is being replicated to. On the primary, you have a vol sender, and on the standbys, you have a vol receiver. So essentially, the write-ahead logs are being sent by the vol sender to the standbys. And when the standbys receive those write-ahead logs, they replay them locally on the database. And that is how data from the primary gets replicated to the standbys. Right? This is kind of how it works behind the scenes at the file system level, physical streaming replication. Now, backups, I talked about how point-in-time recovery, I'll talk about it in more detail, and this is a slide where I am talking about it. Now, the way backups work, in Postgres, the backup will take a physical copy of the file system level data, which is write-ahead logs, and a physical copy of the committed data. The restore, it happens the same way. You can get a physical those physical files can be restored to a different server, to a different node. These are, of course, we're talking about physical backups and restores over here. The tool that is used, and this is a built-in tool in Postgres, is called PG-base backup. And what PG-base backup does is it, at the file system level, takes a physical backup of all the files, of the data files in Postgres, and it uses those physical files to restore onto a different server. Tend to be very fast because there's nothing logical in there. There's no decoding. There's no processing. It's very, very quick. It just picks up those files from the physical system, and you can restore it. And you can also combine this with write-ahead log streaming, wall streaming. And what that does is it gives you a very fast way to implement point-in-time recovery. So remember, I drew that crude timeline where I said that, in Postgres, you have to move forward from that base backup. This is what it looks like visually. What happens is over here, you've got, the base backup, the last backup that you had taken, and then you replay the write-ahead logs till the point in time you want to recover to. And this will give you a time-consistent copy. So let's say at disaster struck somewhere over here, and you want to recover to that point in time and then move forward, you can take the last backup that was taken, the last physical backup that was taken, and then replay all the write-ahead logs on top of it to get to this point, and then you can continue moving forward. Now remember, the amount of time it takes to restore the PG base backup and then replay all the write-ahead logs, that dictates your RTO, the recovery time objective, because the amount of time it will take to get to that point will contribute towards your RTO. In terms of point-in-time recovery, again, one example of needing to kind of roll back, and I think flashback is used in Oracle for doing this. Let's say there's a human error, in this timeline. There's a human error somewhere over here, and you want to recover to a point in time just before this. What you do is that you take the last base backup and you replay the write-ahead logs only till the point in time that you want to recover to. You don't replay the entire logs, because beyond this point, there's an error. You only replay till here, and then you can continue your standard operations. This functionality kind of mimics that flashback functionality that we just discussed. Now, backups in Postgres, we've talked about the physical backups. Now we're going to talk about logical backups. And what logical backups do, it takes a logical dump of the data. And you can actually, with the dump file, it's human readable. You can read that file. Mostly it's stored in SQL format. What a logical dump allows you to do, it allows you to take a dump in one version of Postgres and restore to a different version of Postgres. So let's say if you want to upgrade from one version to the other, you can do it using a logical dump and a logical restore. You can also do it across different types of hardwares and encodings. And it also gives you the functionality to backup and restore selected objects. So in case you want to back up a subset of the database and restore a subset of the database, you can do that. The utilities that are built into Postgres to allow this functionality are called pgdump, pgrestore, and pgdumpall. Using pgdump, you can take a logical dump of database objects, all database objects, tables, views, functions, etc. And pgdumpall captures global objects like table spaces and roles, etc. Both pgdump and pgall, and actually pgrestore as well, they support parallel operations. So in order to increase the speed and efficiency of this dump and restore process, you can have parallel operations ongoing. Logical backups do not support point-in-time recovery. If you want point-in-time recovery, you have to have the physical backups with vol streaming. So that's the downside of logical backups and restore. So a quick table to compare, logical and physical backups. Both will have an exact data copy. Logical backups allow you to do selective objects. Physical backup, it is either all or none. There's no middle ground. You can take a logical backup and do a restore across major versions of Postgres. Physical backups need to be, they need to be restored to the exact same version. You cannot go across versions. Logical backup will not allow for point-in-time recovery, which you can get from physical backups. Logical backups also do not allow for incremental backup or restore, which physical backups do. So in case speed and function, and the exactness of data is of essence, physical backups is the way to go. If you want to do selective, then logical backup is the way to go. For many of our clients, what we have seen is that they implement a combination of the two. The tooling ecosystem, we've talked about this.
I just want to touch base and let you know that we've got 4 minutes to go. Hopefully we can run a little bit over time. But if the session does cut out, we'll find out in 4 minutes if we're able to continue or not.
Okay. Yeah. I think that we are close to the end, but I hadn't realized that we had gone so close to the time. But okay. So the tooling, I won't go too much into detail because we have talked about most of these toolings previously. Pretty much all of them, the ones that you see in backup and restore and orchestration, they're all open source and available for use in the Postgres ecosystem. There is commercial tooling available as well. And one of them is Standby NP by DBVisit, who is my host today.
Thank you very much
and what Standby NP does is it encapsulates that complex functionality that resides inside of the database and gives you a nice visual interface, a GUI interface, so that you can click and point and set up your backup and disaster recovery strategy using it. Similarly, EDB also provides some commercial tooling for the backup and recovery management. But of course, these are commercial in nature. You've got some open source tooling if you know what you're doing, and you've got commercial stuff as well in case you want help from the organizations. The ecosystem is fairly mature, by the way. In case you're wondering how reliable the tools are that have been mentioned over here, but be it open source or the proprietary listing that you see on the screen right now, the ecosystem is mature, being used in production since a very long time, reliable, battle tested. So don't worry about that stuff.
Yeah, I think one thing that I found quite interesting is while a lot of so you've got commercial tools, but while you also have open source tools, a lot of them are kind of, I would say, commercial solutions where in that you might take a long-term relationship with a company like Stormatics or, a plethora of Oracle partners who also offer Postgres services. And they will help you kind of make sense of the different tools that are there, set that up, and also provide some ongoing support regarding those products because, otherwise you will need to have a lot of technical skills in-house to kind of get used to those tools in the initial part.
Yep. Thanks for bringing that up, Tim. And yeah, Stormatics does provide services for all of the tools that have been mentioned, and we also provide 24/7 support for the tools that were mentioned. Some common pitfalls in disaster recovery strategies. I think that these would be common across Oracle and Postgres. Your standbys need to be monitored. You want to make sure that the replicas are not lagging behind. We spoke about that, how it's important to ensure that the replication lag is minimized. And in case it is increasing, what measures need to be taken in order to reduce the lag. The vol files can pile up in case there's a lot of heavy load on either the primary or the standby or both. Vol archiving or vol files might pile up, and that might leave a gap. You don't want that gap because you want to have point-in-time recovery possible. Backups need to be tested. I try and take every opportunity at my disposal to emphasize backups are only reliable if you test them. Schrodinger's backup is not a thing, right? If you haven't tested it, you don't know whether it works or not, and that is of no use, because when you need to use a backup is when disaster has already struck, and you do not want a double whammy to find out that the backup isn't working either. And document your procedures. Make sure that your team understands failovers and switchovers, run drills with them, run practice sessions with them. The run books need to be detailed. Make sure that the team understands the run books. So once you run those drills in a calm environment, the team will have that practice needed when actual disaster strikes. They will be able to follow the drill and go through the steps calmly and execute them to perfection. So run drills.
Umi, I've got another point here which I just wanted to also we think is really important as well, which is because there are a lot of tools out there for Postgres. If you have different people within your organization creating Postgres solutions, you can end up with different databases being set up and disaster recovery being set up in different ways with different systems. So we really like trying to have as much commonality as possible across systems so that, if a team member isn't present, as they're likely not to be on a disaster day, that another team member can take over and handle those different systems. So, creating commonality of how you do Postgres can be a really good thing for you.
Excellent point, Tim. Excellent point. I agree 100%. Much like you don't want a plethora of technologies in your organization, each having requiring a different type of skill set and a different maintenance cycle. You also don't want your disaster recovery strategy to be different across different environments. A singular recovery strategy will help ensure that all teams are completely aligned and they're learning from each other. And in case something goes wrong in one environment, the way to recover is exactly the same across all the environments. I completely agree. I think that's a very good point. A quick case study. This diagram showcases a complete HA and DR strategy that we implemented for a fintech organization that, due to regulatory compliance reasons, had to move away from the cloud and onto a self-managed and self-hosted database within a certain geographic location. So where the cloud gives some very easy functionality for HA and DR, re-implementing that entire thing on a self-managed and self-hosted mechanism was turning out to be very challenging for them. So they brought us in and we implemented this architecture for them. So you'll see that HA and DR are going hand in hand together. What you'll also notice is that instead of having 3 complete data nodes in the site A, we actually have only 2 data nodes with 1 witness. Now, the reason is that one major reason to not have 3 data nodes was they wanted to control costs. Every data node incurs costs. And they were running over budget anyways, and they wanted to reduce cost. They asked us how we could do it, and we said, well, rather than going for a complete data node, we can go for a dumb terminal that will just act as a witness. Now, why is witness required? Replication and failover in Postgres is generally implemented in a quorum-based architecture. So there is voting in that's done, and the quorum that is specified, and you need to have an odd number of votes in order to come to a decision. Right? So it's either 3 or 5 or 7 or 9 nodes that you can have in a system. It can never be even, because even means that you can have a split brain scenario where half of the nodes think one node is the primary and the other half think another node is the primary, and you'll have a split brain. In order to avoid that, we need to have odd, and the witness node essentially is just something that has a vote in that quorum and helps decide which of the nodes is actually the primary node. So that was one thing that we implemented. And then in a remote site, we implemented a warm standby. Again, you will notice that it is not a full data node, right? This is mostly just storage that keeps the base backup as well as write-ahead logs, the archiving, and that allows them, in case the entire site A goes down, allows them to rebuild their database at site B. So this is the architecture that was implemented. The tools that we used for replication and failover for site A, the management of replication and failover in site A was Petroni. The tool used for the backup and write-ahead log shipping for site B was PG Backrest. And we implemented monitoring and alerting for this entire cluster using Grafana and Prometheus. Sorry about that. So the tooling is right there for you to see as well. And this is something that we implemented for a rather large fintech that was forced to move away from the cloud because of regulations and compliance reasons.
This is the first time, I may be a bit ignorant here, but this is the first time I've seen the idea of a two-node Petroni cluster, essentially, with the witness. I mean, coming from the Oracle side, we're really used to having, this kind of disaster recovery or, this data guard with a single node for data guard. And then when you come to Postgres, it's all three nodes. And, I think a lot of DBAs would deploy three nodes just as per normal. But that is, as you mentioned, that's quite a cost in terms of hardware. So this is a really interesting solution to have that witness there. And maybe, you have a two-node there, and then you get greater resilience by having an offsite standby database like you've implemented here. This is, really resilient.
Yeah. Now, increasingly, it's this kind of an architecture that we're now recommending to our customers. We think that it saves costs. We also think that both hardware, network, hardware, network, and data centers are increasingly more resilient and reliable. So we can afford to reduce a little bit of redundancy. So the third node, the justification of the third node, one of them was because of the quorum, but the other was what happens if the issue persists and the standby that has taken over also goes down. You need to have a second standby, right? That was the argument. But increasingly, what we have seen is that the chances of the standby also going down immediately after taking over from the primary are slim enough that we can afford to have this kind of an architecture.
Yeah.
So yeah, this is the recommended architecture that we're increasingly moving towards with our customers. And well, if somebody thinks that their database resides in the cloud, they don't need disaster recovery. We get this, right? We get this question. Hey, we're on the cloud. We're okay. We don't need to worry about DR at all. But they're wrong. That assertion is just plain wrong. And even the top providers, the hyperscaler of the cloud, AWS, Azure, GCP. And by the way, OCI, the Oracle cloud infrastructure, is also now providing database as a service for Postgres. And all of these have both HA and DR strategies implemented in the cloud. In fact, the product owner at Oracle that was designing HA and DR for Postgres in OCI asked for help from our team to test the resilience of the database in the Oracle infrastructure. So we know exactly how it works internally as well. Now, because each provider is giving an HA and DR strategy, and it kind of an indicator that you cannot live without these, even if you go to the cloud. You still need to plan for DR. You want to plan how you want to handle availability zone redundancy. You want to understand the difference between regions and availability zones. You want to understand, can you have redundancy across regions? What does going from one region, one availability zone to one region, multiple availability zones, and further to multiple regions. What does that mean? And how does that impact your disaster recovery strategy? You want to understand that and plan for it. None of these providers support auto failover across regions. They provide auto failover across availability zones, but not across regions. So in case an entire region goes down, how do you plan for that? So the disaster recovery planning still needs to be done. And if you work in an industry that is governed by regulations, and you need to comply with regulations, understand that many regulations will almost force you to have a disaster recovery strategy. Many regulations will ask you to define your RTO and RPO. They will ask you to define your data retention policy, how you are going to recover data in case it gets lost. PCI DSS and ISO 27001 are examples of standards that require periodic DR testing. So it goes without saying that you absolutely need to test your backups and your recovery strategy. And the way you do that in the Postgres world is very similar to how you do it in the Oracle world, as long as you understand how the terminologies and the tools are different between the two technologies. And that brings us to the end of the presentation that I had for today. The QR code is my LinkedIn profile. I'm happy to connect with anyone and everybody who wants to connect. I tend to be active on LinkedIn and respond to questions if you have any. My X handle is PG_Omer, so you can feel free to follow as well. And happy to take questions.
I'm just finishing answering one here, and I'm terrible at multitasking. There we go. Okay, so there's been a few. But I think we've got one open here, which is a bit of a tricky one. Can we deploy a multi-master setup with conflict handling across geo-distributed clusters while using bidirectional replication or multi-master mesh with automated failover? There's a lot.
That's a lot of keywords in there.
Can you see the question in the Q&A section?
I can't, but I don't think I have that interface open. I probably need to figure out how to do it, but I understand the question. Right. So the thing is, with open source Postgres, you can implement bidirectional replication. You can implement multi-active clusters. You can implement geo-distributed clusters as well. What you don't have is conflict resolution built in. If you want conflict resolution, it either needs to be at the application level, the application needs to be aware, or there are some commercial applications or the commercial variants of Postgres where conflict resolution is implemented. Not only conflict resolution, there are actually conflict-free replication data types that are implemented as well. So if you want to set up a geographically distributed active cluster that has conflict resolution built in, you will need to go to a proprietary solution. Open source Postgres does not offer it.
Right, thank you. Okay, some of the other questions that we've answered this one.
Potentially Jaspreet's, sorry if I've said your name incorrectly, Jaspreet's question.
If a logical active, yes, this is the one we didn't get to. So if the logical active replication uses separate storage and replication in the back end, then how is the data consistency maintained in case of network lag or any other issue without performance lag on the database?
Right. So the idea behind replication is that it is a shared nothing architecture. So no data or no server is shared across the nodes. The pro or the benefit of this kind of an architecture is that you never have a single point of failure. Right. The downside of it is that the data is being replicated across the nodes. Now, if you've implemented logical replication, that is not synchronous in nature. And there is an overhead involved with logical replication because when the data gets to the other end, it needs to be logically decoded before it gets, it gets visible to the standby or to the other node. And that, by definition, adds a little bit of a lag. So if you want absolutely zero lag between the two nodes, then you have to implement physical streaming replication in synchronous mode. But if you're doing bidirectional logical replication, there is going to be a little bit of a lag, and consistency within a database is guaranteed because of ACID compliance. Consistency across nodes in a cluster is eventual in nature. And we just have to make sure that the lag is minimized. The replication lag is minimized using best practices.
Okay, really good questions. They're testing us. And there's one open question here. Okay, that's just to say thank you very much. Multi-master. Okay, and I think I've answered this here, but I'll let you answer it as well. It's the first time I'm seeing this, the term about warm standby. Is it possible for you to clarify what warm standby is again?
Okay, so the difference between a hot standby and a warm standby is that a hot standby is ready to take over the moment the primary database goes down or the primary node goes down. A warm standby does not support automatic failover. A warm standby is used for disaster recovery. It's not a complete data node. It is essentially storage that contains the base backup and the write-ahead logs that are being archived. In order to take it from the warm standby to an active node, you need to restore the backup and replay the write-ahead logs and make that node an active node. So it's not immediately ready to take over. A hot standby is immediately ready to take over.
Great.
I hope that answers the question.
No, that's perfect. I know we're over time, but I think it would be great to get an idea of what people's challenges are at the moment with Postgres and where they are, because that helps us make content. And we'd also like to ask you what topic you'd like to see next from us. So we're going to ask you to do a quick poll, if you could. Yeah, especially interested to see what topic you'd like for the next webinar. Hopefully you found today's session really helpful. I know it's been a lot of fun actually talking with you again, Umair.
Yeah, no, I wasn't expecting it to be this interactive, honestly. But the more interactive it is, the more fun it is. I'm glad it happened the way it did. But the downside is that we went over time, and I hope it wasn't too much of an inconvenience to our audience.
Yeah. No, I probably asked a few too many questions there at the start.
No, this is good. This is good.
All right, Erin, have you got the poll results come in there? Are you all good?
Yes, we have got them coming in, and I think we can probably end it here. We've got quite a few answers now. Thank you very much, everyone.
Yeah, I'd like to thank everyone who's stayed on a little bit longer. Really appreciate it. It's great to see you here today. And yeah, we'll definitely make a big effort to get some more great content out to you in a couple of months' time. And please do reach out to DBVisit or Umair and Stormatics with any questions around Postgres disaster recovery. We'd love to help you, in your journey.
Yep.
And have a good day.
Thank you, everyone. Thank you, Tim, and thank you, Erin.
Yeah, thank you, Umair. Cheers, Erin.